It's thinking. Good afternoon. All right, so don't forget, we don't have a class per se on Friday. Well, we're not meeting on Friday, but you could use the class time if you wanted to. That's kind of the idea. Is, you know, we would do the quiz during class time, but then I wanted to have it open, so that's why we're not meeting. But don't forget, no lecture on Friday. Maybe, I don't know, you can do the quiz. Hey, this doesn't look like Friday. That looks like, I don't know what. No lecture on Friday, but you could use the time to do quiz number 2. Quiz number 2. Quiz number 2 is going to be on chapters 4 and 5. Okay. No R stuff. So I've got a lot that I want to go through today, and so hopefully we'll get through all of it. We'll see. But once I start showing you R code, then no, don't worry about that. That's not going to be on the quiz. It's just going to be kind of theory and the stuff that we did in class. So no R on the quiz, right? Just like the last one. It's just on chapters 4 and 5. Of course, they kind of build on chapters 1, 2, and 3, but not really. So I'll just call it chapters 4 and 5. And it will be open now. Confession time. I haven't made the quiz yet, so I don't know when it'll be open, but should be open by around noon on Friday. Open. I'm ready to commit. Give myself a deadline. Yikes. Open at noon on Friday and closes at our usual end time, 11:59 p.m. Right? Otherwise, midnight, that's hard to kind of figure out. It's actually the beginning of the day, right? Confusing. So to avoid that, I do 11:59 p.m. And closes at 11:59 on Sunday, which is what? The 24th. Yeah. It's just going to be a 50-minute timed quiz. 50-minute timed quiz. It's of course open book, and I encourage you to use all your resources, right? Just not each other, right? So good. Okay, so let me know if there's any questions, but we've done one before, so you kind of have a better idea of what to expect. And so, but let me know if there's any questions. Okay, so I think that's what I wanted to do. And in terms of review, we were talking about, so what I'm hoping for today, just so you have an idea of what I want to do, I want to finish chapter 5, kind of the theory material. So just finish association rules, talk a little bit about all the complexities of text, dealing with text in our analyses. And then I want to show you, I posted some code for a code book. I want to walk you through that. And also I posted some code on how to do some of these clustering techniques, or how to use some of these clustering techniques. So hierarchical and k-means clustering is what I posted. So I'll put those off because if we don't have time, then we'll start with that next week. But hopefully we'll have time to go through my entire wish list. And I got so caught up making those documents that no, I have not finished marking your assignments. And I know that that's bad because how am I supposed to know what I did wrong? Well, just try your best and they'll be marked very soon. I promise. I know. I said that last day, I think. I don't know. All right. So, but we did talk about the codebook, so that's why I couldn't find one document that was good at describing what it was, so I decided to just kind of put together my own. All right, so in terms of review, right, we were talking about association rules, right? And so if we have, there, I almost said it. If we have binary information, right? Or if we can create binary information. So if we have binary data, binary, which is 0, 1 data, right? Usually if we have kind of transaction data or something like that, did they buy this item, yes or no, right? Then we can easily convert that to well, I shouldn't say easily, but we can combine that to make binary data, right? And so if we have binary data, we can consider associations between the variables. Okay. Specifically, we're going to have kind of an if-then statement. So if they buy, and we went back to just kind of that basic grocery store example, if a person buys bread and jelly, question? I think not. I'll just mute you if you there. Okay. I'm slowly approaching to mute you. All right. So if a person buys bread and jelly, I think the example was, then do they buy peanut butter as well, right? Can we use those association rules, and can we use those to help us sell more stuff? Right. And so what we have is we can make a statement like, and we set it up like this. If bread and jelly, and we said we could have more variables in here if we wanted to, right? We could focus on one, but maybe we want to look at 2 things. And in general, this is called the antecedent. I didn't look up how to say that. I feel like I've heard antecedent before, but antecedent, I don't know. I need the Google pronouncer to tell me. Antecedent, antecedent. Yeah, I think it's the antecedent. Yeah, the number of times I get the Google pronouncer thing to tell me how to say stuff, it's incredible. Incredible. So if bread and jelly, then peanut butter, right? That's the example that we looked at last day. And this is what we call the consequent. Yeah. And I grabbed that because we kind of cut a text blob in half from last day, so I just wanted to bring it in properly. So if we have some binary data, then what we have is we have maybe a matrix, a matrix sounds, well, it sounds cool, sounds scary maybe, but it's really just like a spreadsheet, right? And so we might have, what's it called, a presence absence matrix, right? So binary data. Oh, I can't spell at all today. Or maybe I can spell, but I can't write. Binary data is stored in a matrix, is stored in a, I feel like it's called a presence absence matrix. Oops. Right, 1 is present, 0 is absent, right? So we could look at, and we had an example of transaction data. So we might have something like this, right? We might have transaction data like this, where it's all a mess, right? Transaction number 1, number 2, number 3, number 4, number 5, and they all bought or didn't buy a whole slew of things, right? And so a store would have a list of everything that they sell, right? And so it's easy for them to create this matrix. And of course it's huge, right? But we're going to focus on whatever we're interested in, right? There's going to be items that are definitely not related and we won't care about those. So we can really kind of zoom in on a specific area of the store or whatever. So if we wanted to make some sort of presence absence matrix here, because this is all mumbo jumbo, we would start with maybe something like bread. And we have transaction number 1, number 2, number 3. And so in the first transaction, they bought bread. In the second transaction, they bought bread. In the third one, they didn't, right? And so we kind of went through and you can generate this matrix, right? So peanut butter, I'll just write, oh, PD, that's professional development. PB, that's peanut butter. So first one they did, second one they did, third one they didn't. Hey, they're all looking the same. Right. And then we can go through, we can do milk. And now first one did, second one did. Oh, surprise, surprise. Third one didn't, right? And so on and so forth. So you can create this matrix, right? A presence absence matrix. Right. And so from here, we said, well, we can calculate what we call the support, right? And so each variable is going to have a support, which is just the sum of, well, the variable, right? Because all the ones will add up and zeros don't add anything. So you can just sum over each variable. So each variable has a support. And maybe I should say each variable or combination of variables because what we could do is, if we're talking about bread and jelly, right? Those two have to happen together for them to form a support for bread and jelly. And so then if we think about, well, here I have milk, so maybe we'll talk about bread and milk just temporarily. I know, I forgot to put it in here. I didn't forget, I got lazy. I didn't put it in. Forget. So let's talk about bread and milk instead. So now they only form a support if both of them are present, right? And so then you can still count that support. And so each variable or combination of variable has a support, which is the count which is the count of the variable or a combination of variables. So we finished, and I keep having to bump this down. Oh man. Okay. Just leave it way down there. Okay. So then we said, okay, well, if I can calculate the support, then we can develop something called the confidence. And so the confidence uses the support. So we said the confidence is the probability of the consequent, well, so similar sounding, given the antecedent. So we know conditional probabilities. How do we find them? Well, we have to find the probability of the consequent and the antecedent divided by the probability of the antecedent. But we can just translate this into in terms of the support, which might be easier to deal with, right? Easier to think about in terms of the support. So the support of the consequent and the antecedent. So that's everyone who bought all three things that we're looking at: bread, jelly, and peanut butter, right? So that's going to have some support divided by the support of the antecedent. Okay. So where we ended off was, maybe I'll bring this whole thing in and grab what I need here. Oops. Okay. So what happens is if the support of the consequent is high, right? So if you're looking for something that everyone's buying, that's going to be really hard to pick out, right? And so then the confidence would be high still, because the support of the consequent and the antecedent, well, that's going to be really large, right? Divided by the support of the antecedent. And so we kind of lose touch with what we're trying to pick out here if we're trying to pick out something that everyone's buying anyways, right? And so that's kind of where we left off, but in comes a way to correct for that, right? So if we have, let's see here, if the support of the consequent is high, then the confidence of the association rule could be high, even if there's little or no association between the items. Okay. So that's the end of our review, and that's where I'm picking up to introduce the lift ratio. So here, now I'll just do the same thing here. Haha. So what we can do is to evaluate the efficiency of a rule. What we need to do is we need to compare this conditional probability with the probability of the consequent. Okay, and so I was going to highlight, but I'm going to hold off. Too much highlighting. I want to keep it important. So what we do is, we compare this conditional probability with the probability of the consequent to see how much more likely the consequent item set is given the antecedent item set versus just the overall unconditional likelihood that the transaction contains the consequent. So what that means is, okay, if we're looking for something that everyone's buying, right? How special is the scenario that we've whittled down to, right? And so the lift ratio looks very similar. Because what we do is, okay, so we could talk about probabilities, but I know most people don't really like probabilities. It's kind of, no one likes them. I like them, but no one likes this notation, right? But if you think about, okay, the confidence of a rule, and then we remind ourselves that, okay, the confidence of the rule, I could actually just talk about in terms of the support. And I think we all have a pretty good understanding of what the support is, right? How many people bought all three things that we're interested in over how many people just bought the first two things that we're trying to use to predict. Shouldn't say predict, but kind of. So we take that confidence, right? And then we divide it by the support of the consequent, okay? So the lift ratio represents how effective an association rule is at identifying transactions in which the consequent item, so the consequent is the part that we're interested in, item set occurs versus a randomly selected transaction, okay? And so here, just in terms of use, a lift ratio greater than 1 suggests that there's some usefulness to the rule, okay? So we kind of take that as a quick rule of thumb, right? But it really depends on the data and you know, how picky you want to be, which leads me to my next point. Well, not my next point. Another point from the textbook that I agree with. So I decided to talk about it. What's frustrating, especially when you're starting, is that we can talk about the support and the confidence and the lift ratio, and we can use those as general guides, right? But an association rule is ultimately judged on how actionable it is, right? And how well it explains the relationship between item sets, right? And so we might get bogged down and we might, you know, develop this amazing association rule, but it's completely useless. Right. And so you have to be really careful. I'll highlight this part. So something actionable would be something like in the example. So suppose Walmart mined its transactional data to uncover strong evidence of an association rule that says, if a customer purchases a Barbie doll, so the purchasing a Barbie doll, that would be the antecedent, right? Then a customer also purchases a candy bar, right? And so that would be our consequent, right? The candy bar. And so now what we can do is maybe we have a ton of leftover candy bars that we need to sell off. Maybe we have a high margin candy bar that we want to sell more of because we make tons of money off of them. Who knows, right? But actionable things, right? And so Walmart could leverage this relationship in product placement decisions as well as in advertisements and promotions, right? And so what they could do is they could place a high margin candy bar display near the Barbie dolls. I always think about that when I'm in the grocery store and I see an item, like they usually have like lip balm kind of placed randomly throughout the store. It feels random to me, right? And yeah, I do. Oh yeah, I need that. Great. It's never where you think it's going to be though. And so that's frustrating. But so someone has decided that, oh yeah, lip balm should go with the chicken broth for whatever reason. Who knows? So maybe keep an eye out for that when you're in the grocery store and just kind of think, Well, I always wonder, is this an employee and just a random employee, a store employee that's gone rogue and just decided to do something funny? Or was there data analyses involved here? We'll never know. They don't put a sign saying data analyses show that this item pairs well with this item. No, they don't tell us that. Okay, so we have these kind of measurements and things like the support. We can talk about the confidence. We can talk about the lift ratio. But at the end of the day, yeah, candy pairs well with everything. That's very true. Right. So we can talk about all these things, but at the end of the day, if you haven't found something that you can actually, suggest to your boss that they should do, then it's not very useful, right? So that's just something to keep in mind for the association rules, right? But if you have found a good association, so on the flip side, if you have found a strong association, how can you support that statement? Well, you can use the support, the confidence, and the lift ratio, right? And so you can use that to back up your statement. Okay. So on the other hand, if you have found uh-oh, my computer is doing something weird. I hope it stays online. All right, so on the other hand, if you have found a relationship or an association and found an actionable association, you can support your findings by talking about the confidence, talking about the lift ratio, right? So you can support your findings. Tricky because I use the word support, but of course the context means it's something other than the data support, right? So you can support your findings by reporting the confidence, and lift ratio, and possibly the supports, right? The confidence uses the supports, and so we wouldn't really need to state them explicitly, but maybe if you feel like you've got a support showing off, worth showing off, then go for it. And possibly the supports. Okay, so support your finding by reporting the confidence and lift ratio. There, I'll end it there. On the other hand, if you've found an actionable association, you can support your findings by reporting the confidence and lift ratio and possibly the supports. Hey, kind of makes sense. Good. All right. So the last little blip in this chapter is on text analyses. So text mining, and of course there's not a lot to talk about here, ironically, because it's text. Oh, and I was able to find the transcript for our classes. The problem is it's all broken up, all weird. So I'd have to kind of clean it up before we use it. And also, it picks the wrong words sometimes, which is also a problem, right, with text mining, which we'll see here. So let's start here. Okay. So text mining is its own beast. Okay, it's really common because a lot of the data that we have available to us that we're interested in comes from text, right? So for example, I didn't realize that it was so many tweets, I guess, but 500 million tweets per day, typically. So we could look at a day worth of tweets, right? And that would be tons and tons and tons of text data, right? So just a day's worth. So now imagine a week's worth and so on and so forth, right? And so just kind of crazy amounts of text. So the problem is that text is what we call unstructured data, okay? And so you can collect it the same way that we do, but it can't be stored in a nice spreadsheet form initially, okay? So here I'll just highlight where we're at. Okay. So we call it unstructured data because it can't be stored in kind of a matrix form like we did with that transactional data, right? Where we have observations in the rows and then variables in the columns. We have to create those, right? And that's going to require a lot of work. And sometimes we're able to automate it. Sometimes we just have to do it ourselves. And that sounds terrible. I've done it, so I'll tell you it's terrible. Right, and so just as a side note, if you have audio data and video data, you're the NSA, for example, then you have all this unstructured data, and you need some method where you can automate structuring this unstructured data. Okay. Okay, so we call this pre-processing, right? Where we convert text to a format that we can import into R, or typically for kind of these huge data sets, we would use Python, but R is fine. And there's all kinds of different things that we could use, but let's just talk about text analysis. What is it? So what we have to introduce, just like we talked about the support and things like that, we have to introduce some terminology. And so if we have text that we're dealing with, okay, then we're going to call those documents. That's not so weird, right? And a document is made up of terms. Okay, so a document can be a single sentence or an entire book. And I did come across, there's a package in R that has all the Harry Potter books. So you can bring in all the text from the Harry Potter books. So maybe we'll do that as an example, because I think that's really fun. And also you could read the Harry Potter books, finally, right? Or maybe again, I don't know. I think I read the first 3 for sure. And then I kind of dropped off, but she was taking too long to produce them or to put them out there. You have all of them, but have you read all of them? Yeah, I've got lots of books too. I've read, there you go. Hey, we're all Harry Potter fans. They're really good. Yeah, I'm like, yeah, I've got tons of books too, but that doesn't mean I've read them. So need to clarify. So I've got a big pile of books that just haunt me. They bring me joy because I'm like, oh yeah, I'm going to read those out at some point. And then, but they also haunt me. I just move them around. Anyways. Okay, so we've got all these terms, right? And so what we're really analyzing are these terms, okay? And so what we can do is we can talk about a collection of text documents, right? Yeah, the movies, no. You always have to read the book before you watch the movie, and then the movie is no good. But sometimes I don't want to ruin it, and I just watch the movie and I don't read the book, because then it's okay. when I was younger, like really young, I read Gone with the Wind like 4 times over. I love that book. And then I watched the movie and I'm like, hey, they forgot a husband. They forgot all this stuff. I was really mad. So anyways, but that's neither here nor there. So what we have is we're going to call, we have a corpus of documents. Okay. And so, and that's just to keep things straight. So imagine you're Amazon and you're looking at the reviews for one item, right? So each review would be a document made up of terms, and the collection of reviews for one item would make up a corpus. Okay. So for example, reviews for an item on Amazon, right? Each review is a document, and maybe I'll do it like this, just so we can keep them straight, right? Is each review. The terms are, of course, the words in a review. Words in a review. Oops. And the corpus is the collection of reviews for one item. Reviews for one item. Okay. Just for a little kind of example there. So what we need to do, what do we need to do here? So you imagine you're reading these reviews, and one thing that I'm not sure how they deal with, I don't know, how do they deal with sarcasm, right? And so for example, oh yeah, this chair was so amazing, it fell apart on the first day. So they've got this keyword that's amazing, and then it fell apart, and so that's kind of counteracting the amazing, and so that's something that you have to deal with. Okay, but what we can do, and what's kind of common is, oh, I see I erased too much here. That's okay. I think you get it. Collection. So bag of words just throws everything into a collection. So it doesn't look at sentences. It just looks at kind of a bag of words, and then it arranges all those words into kind of a matrix. And so it's simple, but often effective. Okay, and so it doesn't consider things like grammar, word order, or sentence structure, right? Because it just kind of, you can imagine you've got this kind of constructed sentence, and then you just cram them into, they just kind of fall into a bag of words here, and now you just have a bunch of words that you need to work with. Right. And so that's not always going to work, but it's simple and effective. So what we do, if you have a bag of words, now all of a sudden it's easy to organize all the words, right? Did this document have this word? Yes or no? Yes, it did. Gets a 1. Great. Moving on. Right. So as soon as you have all possible words together, then you can make this matrix, right? It's going to be huge, not just this big, right? And so, but you can construct this matrix. And so, so what we can do is we can make you know what? I don't know if there is a way to deal with sarcasm. They must have some way where maybe a document gets flagged if it has kind of counter 2 words that counter each other. That's how I would deal with it, kind of initially, just off the cuff here. I would develop some sort of mechanism that would flag if I have two ideas, so kind of two sentiments that counter each other. That would be just kind of one idea that I can think of. I'm sure they have something, you know, the brains at Google, etc. They're working on something. I'm sure of it. So what we can do, right, as soon as we have the collection of all the words, then we can construct this presence, absence, document matrix or document term matrix, right? So we have each document, right, which is an observation. So here you would have document 1, document 2, document 3. And now all of a sudden it looks a lot like term 1, term 2, term 3. Right? Now you can construct this binary matrix and all of a sudden it's looking like that transaction data, right? It's going to take a lot of work, right? And so to construct especially these terms, so it's not just good enough to have individual terms. We need to group them so that we can have kind of actionable results. And so here, right, term 1 might be, maybe I'll change this. Maybe I'll change it to some terms. Maybe awesome. Document 1 said it was. Document 2 did not. Document 3 also used the word awesome, maybe. How about if the second term is terrible, then maybe, just maybe, it was not in the first document, it was in the second document, and maybe all right, that would be a flag. And now I'm drawing a blank, but term 3 might be something stupid. Well, there's no stupid, but maybe they use the word day. Can't use that. It depends on what we're talking about though, but in general, right, that's not a word that we're interested in, but it'll still be present or absent in each of the documents, right? And so maybe they all use the word day, for example, right? Maybe none of them did, I don't know. Well, none of them did, then it wouldn't be in the matrix. One of them had to. Right, so we can construct this matrix, right? So once we have all possible words, right, from our bag of words, we've taken all our documents and we've shook out all the words and they're just scrambled in there. And then we can list all the words that are in there, right? So now our next job is to combine similar words, right? And so there are methods to combine similar words. We usually want to combine similar words into one column or one variable. Right, just so we can just combine them, right? If the sentiment is the same, then we usually combine them. Okay. So if the sentiment is the same, we usually combine the words. So when I was working in market research, we get all this survey data, right? And as soon as you have a little box that says, please explain, then you type in your answer. Someone somewhere sits there and reads all those comments, right? They're in a, you export them and you read them all, and this is not precise at all. I personally would sit down and I would jot down kind of the general idea of each comment, right? And so things like great, or now I'm stealing from the example in the textbook. There was an airline example where the seats reclining were acting up or something like that. So then it would be classified as a seat recline comment, right? And so on and so forth. And so you could classify them that way. Just someone has to read them and actually do the classification. That seems tedious, right? We don't need to do that, but if we have small data sets like we did, then it's probably easier to do that than to build some sort of huge algorithm to apply, right? Whereas if you're dealing with Twitter or tweets, then of course you want to have some algorithm that does all that heavy lifting for you, right? And then maybe flag some that says, hey, could you take a look at these? Just tell me what to do here, right? Okay. So what we can do is there's lots of ways that we can combine terms, right, that have the same sentiment. So it's called tokenization, right? And so what we have is we divide the text into separate terms, okay? And so first it just kind of clears out all the mess. So it clears out punctuation, it clears out capitalization, things like that. And so if we have, let's see here. Okay. Is not straightforward. Okay, and so the process of identifying tokens, so tokens would be those keywords that we use to summarize the sentiment. Okay, and so the process of defining these tokens, okay, and I'll define the tokens over here because I have some room here. The token is the key sentiment, right? Either of a word or potentially the entire document, but usually the word of the word or potentially the document. A document could have multiple tokens, right? So they talked about how awesome it was and how great the seat recline was. I don't know, I'm just stealing from theirs, but right, that would be two tokens that are present in that document, right? And so what we can do, right, is symbols. Oh. So term normalization is kind of natural language processing techniques that map text into standardized form. So first thing that we do, yeah, emojis, there's a good one. What do you do with emojis? Someone sends a sweaty smiling emoji. Someone sends a running emoji. What does that mean? Who knows? That's probably a whole other field, I'm guessing by now. So awesome exclamation mark, awesome lowercase, hashtag awesome, they would all be converted to awesome, right? And then we do things like stemming. Stemming is where we just take the root word, right? And so things like stacking, stacked, stack, right? Those are all the same thing. So that would be the stem. And so we call that stemming. Okay. And so what we're trying to do, the goal of pre-processing is to generate a list of most relevant terms that it's sufficiently small so that we can actually use it, right? If we have too many words in there that aren't really contributing, then we can't do anything with that, right? So what we can do is, on top of stemming, we can talk about kind of frequencies. So how frequently is a word used in a document, right? And we can remove stop words, the, and, of, right? And things like that. Those aren't really going to contribute to any analyses, right? Because they're not doing anything. They're just linking words together. And so, for example, courteous, cordial, and polite, right? We could just lump those into polite, right? That would be our token. Oh. It says right there. I was going to write token beside it, but it says single token. So, okay. And then finally, the last thing that I want to talk about here is just kind of cute word clouds. They're pretty fun. They were all the rage for a while. Oh yeah, but can you make a word cloud? Sure thing. As long as you have all the words, it's easy, right? You look at the frequency of each word, right? And then depending on the frequency, that dictates the font size, right? And then you just make a cloud, right? And so here, it's a visual representation of a document or a set of documents. So depending on what you want to talk about, right? Is it a bunch of reviews? Are you trying to summarize something for, I don't know, Amazon? Then it would be all the words from all the reviews for one item, right? Or are you looking at a book, right? Maybe Harry Potter, the first one. I don't know which one it is. Right, and so the size of the word is proportional to the frequency, and it's just kind of a cute visualization. Okay, so that is the end of chapter 5. So quiz number 2 goes up to this point. Quiz number 2 goes, or covers material, I should say. I shouldn't say goes. Covers material, covers the material up to this point. I want to highlight that because there's some more things that I want to talk about, but it involves that RMD file, or those RMD files that I posted on Moodle. So let's see here. Any questions about chapter 5 before I put that down and change things up here? Let me close this here. I'll let you think of some while I switch over. I'm going to stop sharing here. Got it? Okay. And then I want to share here. Why is it so hidden? Share screen. It's all green, of course. Let's do my entire desktop. Otherwise I get lost. I can close. This can go down. And let's make this nice and big here. Whee! Then I'm going to zoom in on this text here. How did I do that before? Oh, look at me go. I remembered I wanted the iPad here for a reason, because then I can actually see and make sure that you can see what I'm seeing. Okay, so I posted 2 documents, and you can open them just by opening a new RMD file and then just clearing it out and pasting all this stuff in. That's probably the easiest way to do it. Okay, and so let's see here. Okay. All right, so for now, I posted this clustering in R, but I'm gonna parking lot that until probably next week. I feel like I'm gonna run out of time here. So I do wanna look at this code book in R. Kind of cheeky, I made the output just a PDF right away. So hopefully you have that up and running, and which I saw you were able to do, so that's good. Right, you were able to knit to a PDF, so it should work, okay? So a code book, and what I wanna do is I wanna show you at the very bottom of this file here, because there's a lot of stuff going on here. I did post 2 links that I made use of. I stole shamelessly from Joe because he has this RPubs document here, or it's kind of a website, I guess, where he's put together a bunch of stuff for this course. I haven't given it to you, maybe I should have, but I felt that it was really kind of overwhelming to start off with. So now I'm just going to kind of feed you whatever we need as we kind of go through it. So otherwise, if I just send you to this page and say, figure it out, that's really hard, right? And so I don't want to do that. But everything about the code books or the initial information I just stole from this Data Science 300 main page. The other reference that I ended up using is from this metadata or data meta situation here. And so you can check that out, but I took it and I simplified it. And then I'm giving you an even simpler option because it doesn't have everything that we want. Now, just a little background. So a code book can also be called a data dictionary. Okay, so we can knit this, and let's see if everything works here. I hope so, because I knitted it earlier, so hopefully. Let's let it generate. But that's easier to read if we want to just read a document here. And so what is a code book? A code book is also called a data dictionary. So usually I would call it a data dictionary, but I guess in business they like calling it a code book. And I suspect the reason for that is because they probably used to use SPSS a lot. So SPSS is another statistical programming for the social sciences, is SPSS. And what it would do is it would have a separate page where it would have a code book that you could maintain. And so I think when people moved away from SPSS into R, there were some people who felt like, oh, I need a code book. How am I supposed to survive without a code book? So here we are making code books. That's fine. You don't really need to, because R kind of generates its own code book, but it's not as nice looking. And so what is a code book? A code book is just information that someone would need about the data if they're going to be analyzing it, right? Things like how big is it? When was the data collected? How was the data collected? Just all those things like that. Hey, nice. There's lots of different things that we could include in a code book. And so there's no right or wrong way to do a code book. And I'd love to see your take on a code book. because I've just cooked up something, you know, off the top of my head. And so here it does, just as a warning, it does say the best code books. Let's see if I can zoom in here. Because I'm sharing this. Can I go a little bit? All right. Guess I could have just done it on the whole page, but whatever. So here, there, that's better. I mean, you have the document. I posted the PDF as well, but right, just this says the best code books. Now, I'm not expecting the best code book, and sometimes we don't have all of this information, but ideally, an ideal code book is going to cover all of these things. So, for example, who did it? Why did they collect this data? How did they collect this data? Right? What population are you focused on? How did you collect your sample? Right? So we can kind of analyze how the sample was collected. Just kind of all these things. Sorry, I want to keep an eye on the chat. Let me see if I can grab it. I can't see it. I don't know where it is. How do I? Well, if you're saying something in the chat, I don't know. Can't see anything. And you can't tell me about it in the chat either because I can't see it. How do I get back there? Dang it. That's not it. No. Cancel. Oh my gosh. I don't know. Anyways, hopefully it'll tell me. Doesn't matter. I guess I can pull up the, there. I have the chat on the other side on my iPad. Okay, that works. How do I move this? Can't win. All right. So basically just everything that you need to analyze this data properly. So you can talk about the number of observations. That's pretty typical that we include. The number of records per observation, maybe. The structure of the data within the file, that's not going to apply to us. The details about the data. So oh, here, it popped up, finally. Oh, nice. Thank you, because that popped up my chat. Okay, so details about the data, right? What type of data do you have? Is it numerical data? Is it character data? So character data is what we're going to use to talk about categorical data, because character data is going to be text. And so that's usually how we talk about categorical data, is it's text. And so we could even include things like the text of the questions and the possible responses, right? We could basically incorporate the entire survey if we're talking about survey data, which we're not going to be doing in this course, but it's something that we could include. You could make a huge code book if you wanted to. So some key things that we could include: variable names, right? That should probably be included, right? What are the variables in your data? But also the variable labels. So the variable labels, so the variable names will have things like maybe is it the SKUs? For if we're thinking about a grocery store, so we could have the barcode, right? That would be each of the variable names, right? because those are unique for each item in the store, right? But then, of course, that doesn't mean anything to us. So then we would attach variable labels, right? Maybe a 11024 is bananas. So then we put a variable label that says 11, I can't remember what number I made up, but that's going to be bananas, right? And so the variable labels are really useful because they're kind of the longer descriptions of what the data is. Okay? If you have variable codes, you should include them somehow, right? Include them and say, okay, 0 means no and 1 means yes somehow, and I'll show you how. Or I'll show you one option. Lots of different options. The variable formats, that's not really going to apply here for us right now. One thing that we do want to talk about is missing data. So for a lot of our data sets that we're working with, we're not going to have to deal with missing data, because dealing with missing data is its own kind of field of study. So, or its own kind of beast. So we're not going to deal with that. So it's not really going to apply, but we should just, for, being proper, we should include the missing data. How many missing data points are there? Okay. So date variables can be really tricky, and there's lots of debate and a lot of strong feelings about how dates should be recorded. And so I don't think we have to deal with dates quite yet. Days of the week, yes, but not dates. So I'll hold off on that. But just in general, if you're working through examples that you find online, then a lot of data sets are built into R, right? And those data sets will have some version of a data dictionary. So you can use that and just kind of grab information from there. So for example, if we want to see the MT, I can't remember, I can't remember which way Americans do it differently, and I can't remember which one's which, but I think it should go kind of size-wise, in my opinion. Shouldn't it go year, month, day? Anyways, you can see the debate. For sorting reasons, I would probably use, anyways, doesn't matter. But you have to be consistent in how you store your data, right? So if you use month, day, year, then that's different from day, month, year versus year, month, day, right? Right, and so you want to keep track of which one's which. So the first thing I want to do is just show you all the data sets that are built into R that you can use, that you can check out. And so if we talk about the MT cars data set, which I feel like I've brought in before, it's a pretty typical example data set because it's nice and small and reasonable. What you can do is you can throw a question mark in front of the name, and then it'll bring up the data, or the data dictionary or the code book. Let's see here. So if I do data, right, and I just kind of use empty brackets there, then, oh, I don't want just the air passengers. I want to look at all these datas. Okay. So it'll break it up. It says data sets in package data sets. So notice how it popped up in its own kind of window here so we can read it. I like the chick weight data because it's really cute to say and think about. It's the weight versus the age of chicks on different diets. And so air passengers is a really common data set that we use. And so there's lots of quarterly earnings per Johnson & Johnson share, for example. There's lots of data that's built in that you can look at. But one of those data sets is the MT cars data set. So if I go down here and I say question mark MT cars, enter, down here, and I'll kind of bring it because it's all zoomed in here, so I'll make it bigger. So we've got a description, right? The data was extracted from the Motor Trend magazine, so that's the MT, right? And then it's called MT cars. That's just for the usage in R. And so the format, here's what I mean by the format is it's a data frame with 32 observations and 11 numerical variables. So all of these are stored as numbers. I'm pretty sure we've looked at some of these and we said, well, they're not all numerical, but they're all numbers, right? So the transmission, 0 is automatic, 1 is manual, right? 0 for the engine, it means it's V-shaped, etc. So it's categorical data, but it's stored as numbers. And they have this note, right, that you might be interested in if you're analyzing this data, because in 1981, they decided that, okay, well, they coded the Mazda's rotary engine as a straight engine just for simplicity's sake, and maybe you want to consider that in your analyses. So everything that you would need to analyze this data should be in your code book, and that's kind of your guiding idea. So I'm going to scroll through here, and I went as far as the notes. Okay. Now, because I'm running short on time, I'll leave this codebook example for the CDC Zika data. It's quite a bit more advanced than what I'm expecting, but it is kind of a fun thing to try out. It only talks about the variable names and the variable labels. So it only considers those two things, whereas we want to look at more things. And so it is more advanced, but not as broad. And so here I've got the description, the sample information, just so you get an idea of what to include. And then what I wanted to do instead was for kind of a simpler example. You've all worked with the Heavenly Chocolates data. And so that's nice because we're familiar with the data. And so I wanted to show you what we could do with the Heavenly Chocolates data if we had to make a code book. So if you haven't installed the package, the knitter package, and I see I'm missing because I already had it installed, so that was fake, but you're going to want to add that, and I'll update the code that I posted. You should install the package. You only have to do that once, the knitter package, but then we do have to call the knitter package or the library, and this is for the cable command. Okay, so cable creates these nice tables, or knits these nice tables, I should say. So first thing I usually do is I set my working directory. You can do it explicitly here, or you can go to the session tab and set working directory, and you have a lot of different options. Wherever your working directory is, that's where you're going to store all the files for this project. Right. And then if you move the files, you're going to have to change the working directory. So I just like to have it there explicitly so that I remember to check. Then I bring in my Heavenly Chocolates data. I saved it as a CSV file instead, and then I brought it in and I saved it as HC. So if I set my working directory here, and I bring in my HC data, you couldn't see it because it was hidden, but now it has the HC data here, which I can, if I move this here, which I can drop down. And this here is basically a code book. And not very nice, but it is. And so we're just trying to clean that up and make that look a little bit nicer. So what I have is we can create the bare minimum code book using the str function, which I think is string or can't remember. But anyways, if you run it on the entire data set, you get something that looks like this. Okay, so notice how it tells us it's a data frame, okay, with 50 observations of 6 variables. So that would be part of your code book now, right? You take that chunk of information and you just write it out so it's nicer to look at. Then we have each of the variables, right? So each of the variable names here, and it tells us what type of variable it is and what the first few values are. Okay. And so what we can do is, or what we want to do is present this information in a readable table. So this is by no means the fanciest way that we can do it. I am trying to make it kind of accessible to everyone, so I'm not getting, you know, crazy with all the coding and all the fancy things that we could do. So there's going to be a lot of hard coding, which eventually we'll move away from. But for now, what I'm going to do is I'm basically going to create my table, right? My table values or my table headers one by one. Okay, and I'm going to store them in its own column temporarily, and then I'm going to bind them together using the cbind, which binds all those columns together to make a table. Okay, and so the variable names is the names of the Heavenly Chocolates data. So I can run just the names of the Heavenly Chocolates data by just highlighting the chunk I want to run and then running it, Command Enter. And so then here I have the names, right? And so those would be the variable names. Now, when I run variable names is assigned to the names of, or sorry, I should read it the other way. The names of the Heavenly Chocolate data is assigned to something called var names. So now if I run this whole thing, we didn't see it here, but now I have a thing called var names, and it has 6 entries. So then if I want to make a kind of construct a list of, it's going to be 1 column and 6 rows. Because now we're constructing these kind of vector style things that we're going to just put together to make a nice table. So then the variable labels, this is where you have the chance to kind of elaborate on what each of these things are. Now, a lot of them are going to be obvious because that's the idea with the variable names, they should be obvious. But here, so customer is the customer ID, day is the day of the week. And what I'm doing is if it's text, you have to wrap it up in quotes. Right, and then you can just separate them by commas, and that's going to make a new line or a new row of information. So I can run, well, I can run this if I want to, but it's not going to look like much. It just becomes a list of items, right, or text. So then I can talk about the variable type, and notice how I have to keep track of where each variable is here. That's pretty tedious. I'm using integer for whole numbers to differentiate from numerical data, but integers are numerical data. Characters for categorical data, and then numerical, integer, numerical. Okay. So if I run this here, right, now it saves all these. Oh, I didn't run the variable labels. That's okay. No, it's not. Going back. Okay, and so these are just some of the things that I've done. I fudged the variable codes, right? Because the first one is the customer ID. It doesn't have any codes. But for the day of the week, we want to list what all the possible values were. And I've just listed it as 1 text string. Okay. And then same thing for the browser. I just listed it as 1 text string. And then for any numerical data, there's no codes required. So I just put a dash in there. Just had to fill it with something, right? Because when I make these, when I collate these columns, right, they have to have the same number of rows. Here's where I got a little bit crazy. And what I'm doing is I'm summing up the the number of trues for is.na. Is.na just runs through the customers and checks, and it returns a true if it's missing and a false if it's not. And I can sum those and I'm going to get a bunch of zeros. So now I'm ready to make my dictionary. And I know I'm out of time, but I also feel like you can decide to stay or go, but I'm going to finish this just for completeness sake. So now I'm going to build my dictionary. So I'm going to use the cbind command, which binds all my columns. And I need to list all the columns, and this is the order that they're going to go in. Okay. And so if I build this dictionary, first I'm going to just look at what cbind of this looks like. Oh, barcodes. I forgot to run one of these. That's okay. And run that again. So now it shows me what this table would look like. Pretty messy, but that's okay. Now, what I want is, instead of having var names and var labels, and this is just me being picky, is I wanted to change the names, but it'll only change the names the way I want to do it if it's a data frame. So I'm going to save as.data frame. So I'm going to apply as.data frame to the dict, so the dictionary, and then I'm going to save that in dictionary. And so you can't make it pretty later. We want to do it here. And so, so here I'm saving it as a data frame, and then I'm saving it as the same word. So basically I'm overwriting the old dictionary with the new dictionary, which is a data frame. And then I can use the names of the dictionary, right? Which only works for data frame. And now I'm making these fancy label headers, or yeah, the headers. Okay, so I'm going to run this chunk here. And now we have this dict that we can use, which is a data frame. And now what I'm going to do is I'm going to use the cable command to generate this nice looking table with a caption, data dictionary for the Heavenly Chocolates data set, for example. So if I run it here in R, it's not going to look like much. Oh, because I haven't brought in the knitter library. Now it'll be happy. Whee. So now if I run this cable command, it writes it out all weird, right? But when you guys made your tables in Markdown, right, it looked like this. And so now when I knit this, it's going to generate a nice looking table for me because I worked so hard. And it's going to be at the bottom. Ta-da! I'm so zoomed in, but ta-da! One code book or data dictionary option. And then I have a final note here that says we could also add, where's my mouse? We could also add columns for the range, so the minimum and the maximum value, or potentially the units for any numerical or integer data that we have. So those are just more things that we could add on, right? But if you want to just start with something like this, I think that's really good, really awesome, and have some sort of description of the data. And I think that'll be really, really good. And I'll be so impressed. Okay, so that's, well, not all I wanted to go through, but that's all I have time to go through today. So I'll save the clustering data, and you can look at that code that I posted, but I'll save that for Monday. All right. If you have any questions, let me know. Otherwise, I'm going to stop this here. And yeah, if you have any questions, let me know. Otherwise, good luck on quiz 2, and I'll see you on Monday. and stop here.